Hi guys, hope everyone's been having a great rest of the week so far. This is just going to be a quick tutorial on how to do these t-tests again in Excel. Some new stuff that I found out after experimenting a little bit and testing some things, which should make this a little bit easier for you guys to do. But yeah, let's get started. So first of all, like we mentioned in class, the first thing we're going to do is we're going to calculate these mean averages for all of our combinations of components. So, components of fitness again, and treatments. So fairly simple. We start off by doing our equal sign. Anytime we're entering a formula, we always start off with an equal sign in Excel. And then the function we use is called average. What it's going to do is it's going to let us select these cells which we want to include in the average it calculates, right? So it's as simple as that. That's our average 15.28 for our green morph component 1 treatment 1. All we then do is drag this down all the way, and those are our averages for all of the morphs, all of the components for this treatment. Very, very similar for standard deviation. This time we're using a function called STDEV, very, very aptly named, of course. Um, and again, we just highlight the cells we want to include in our calculation. We hit enter, and there's our standard deviation calculated. Do the same, drag down the column to get your calculations for all your rows and all your components and treatments. Well, just for a single treatment for now at least. And then for SE, again, the formula for this is our standard deviation divided by the square root of our n value. You can see this n value here on the right. In this case, we want to make sure we just type that out explicitly, just because it helps when we're dragging and trying to generalize across all of these rows. So there's our SE value. We drag, and there we go. That's calculated. Now to actually calculate what this t statistic should be. So start off with the equal sign. Remember, the formula is the difference between our means, right? So there's our first mean, and there's our second mean. We're doing these comparisons between these green and these yellow-green morphs, right? So for each component, we're going to have a separate t-test statistic. So difference between the means, and then we divide that by the square roots of the standard deviations squared. So one thing to keep in mind is that this formula can get a little bit complicated, so make sure you're pretty liberal with the amount of these parentheses that you use. But again, the standard deviation for our first sample squared divided by our n value, which again is 10, right? We close off that bracket, we add, and then it's the same thing again, so we can just copy actually and change the cell that we're going to be doing this with. So instead of 03, we highlight the 03, and it's actually obscured it right now, but that should be 04 is what we're doing. So that's that. We finish off and make sure all of our brackets are equal. So there's a left and a right bracket. We press enter, and there is our t value for that comparison. So it turns out you can actually drag this all the way down, and it's going to calculate your t values for each of those comparisons. So here's our first one for our plant shoot length. Here's our second one for our number of flowers. And here's our third for number of leaves. Okay, disregard this fourth one. It's trying to calculate a t-value for this yellow-green morph compared against nothing, but of course we don't want to do that. So we're only going to use these first three that it gives us. And that's it. That's all you need to do to calculate these summary statistics and then do our statistical testing for this first treatment. And then it's you guys are going to be amazed at how easy it is to apply this across all the treatments. Basically, all we're going to have to do is select all of the cells in these four columns and all of the rows, right? So command copy, copy everything. Go over to your second spreadsheet. Again, this is for treatment 2, right? And then we just copy. And this is actually already done the calculations for you. It's the same cells that we used in sheet one for treatment one, except the values are just different. So we can use the same formulas and it's super, super easy and it takes like literally a second to do. So again, to do our treatment three calculations, we just do the same thing again and voila, it is literally that easy. Sometimes you might see something like this where you have a negative t statistics. What's happened here is it's tried to take the mean, the difference between the means of 4.7 and 6.8. And of course, if you do that subtraction, then it's going to be negative. So fairly, fairly simple to solve. Just reverse that. So instead of n7 minus n6, we would do, instead of n6 minus n7, we would do n7 minus n6. And then there's our actual t-value. So again, really, really simple to do, and that is all of your calculations done for this week. You're going to enter these values into your post lab table, right? So this is a copy of what you guys have in your physical post lab. Your first column, of course, should be these components of fitness that we measured. There's three of them, right? And then each of these cells is representing the different treatments that we went through. So treatment one, no competition, treatment two, intramorph, and then treatment three, intermorph. This first one, what we're going to want to do is we're going to want to say, say we're comparing between our green morph and our yellow green morph, right? Or treatment one and looking at plant shoot length. We're just going to do, oh, I accidentally pasted the formula. I have to do that a lot. So I've done this many, many times, still always forget. So it should let you do. I think it's actually gotten that out of the system. So let me go and copy that again. There you go. So very simple. We're going to do this is equal to our second mean, which is taken from our yellow-green morph, right? And there we go. So that is what this cell should look like. I would recommend doing this by hand since it's a little bit cumbersome to copy and paste everything into like this digital spreadsheet, but that's basically what it should look like. This will be equal, and then for this second column, this alternative hypothesis column will be not equal. For t-value, you just copy your t-value that you have here, 1.49, right? And then for your null rejection, remember we're comparing against this this t-test chart that you guys have in your lab manuals. This is on page 414. So given our degree of freedom, which is 18, right? What you want to do is you want to go to row 18 and then you want to compare this 1.49 value against the different threshold values associated with the different confidence levels. So the lowest confidence level they give you is 90%, right? So that's the minimum confidence we need to have in order to say that we reject the null hypothesis. In this case, the 90% confidence value for 18 degrees of freedom is 1.734. And obviously 1.49 is less than that. So we would say that we do not reject the null hypothesis. Um, but that's basically all that you have to do. All that's left is to turn these mean and these standard error values into plots, which I'll show you guys how to do in just a second. But yeah, let me know if you have any questions. I answer your well, I try to answer your emails as fast as I can, usually within like a couple of hours or so. And I'd also be happy to meet and talk about any of this stuff if anybody wants to do that too. But yeah, I hope you guys find this helpful.